Integration by substitution. Integration by substitution is a technique used when you have complex functions to integrate. It is really the inverse of the chain rule. You take a complex function which you need to integrate. You can see the function g of x and its derivative g dash of x. You can look at g of x as the parent function and g dash of x as the baby function. You put the parent function equal to u and differentiate it to get the baby function. You then have a new function in terms of u and du that is easily integrated. There are a number of different methods to integrate using substitution. I'm going to use a method that I think is the most or the easiest, which involves division. Use integration by substitution to find the integral of 2x plus 3 times x squared plus 3x raised to the power of 2 dx. The parent function is x squared plus 3x. Put that equal to u. So we write u equals x squared plus 3x. Differentiate that, so we get du over dx is equal to 2x plus 3. We can now rearrange to find dx. So du equals 2x plus 3 dx. So dx equals du over 2x plus 3. In this method you will always get a division, so we can write the new integral. I'll change colours. So we want the integral, put your division in. So we get 2x plus 3, that's still there. We can substitute in for x squared plus 3, that is u raised to the power of 2, and now we can substitute in for dx. So we get du over 2x plus 3. They cancel, and we're left with the integral of u squared du, which is equal to u, add 1, divide by 3, plus c. Move it up a little to get a bit more space, and substitute back in for u. So therefore, the integral is x squared plus 3x to the power of 3 divided by 3 plus c. Let's do another one. Use integration by substitution to find the integral of 12 times 3x plus 1 cubed dx. The parent function is 3x plus 1. Put that equal to u. So we get u equals 3x plus 1. Differentiate, so we get du over dx equals 3. Rearrange to find dx, so we get du equals 3 dx. So dx is equal to du over 3. Just going back, please note that du over dx is 3. That is not exactly the same as 12, but 12 is a multiple of 3, so that is fine. Now substitute back in, and remember we will have a quotient. So the 12 is still there. 3x plus 1 is now u, so we get u cubed. And dx is now du over 3. So that will cancel to give 4. So now our integral is 4 u cubed du. We can bring the 4 outside, so therefore we've got 4 times the integral of u cubed du. Therefore we've got 4 raised to the power, divide by the new power, plus c. Sorry, that should be 4. They cancel. So therefore the integral, substitute back in, we get 3x plus 1 to the power of 4 plus 3. Let's do another one. Use integration by substitution to find the integral of x squared over x cubed plus 1 dx. The parent function in this case is x cubed plus 1. So make that equal to u. So we get u equals x cubed plus 1. So du over dx is equal to 3x squared. Rearrange to find dx. So du equals 3x squared dx. So dx equals du over 3x squared. Note again that du over dx is equal to 3x squared. X squared and 3x squared are multiples of each other, so that is fine. So now let's substitute back in. So we want the integral. We know we're going to get a division. So x squared is still there. X cubed plus 1 is now u, and dx is equal to du over 3x squared. The x squareds now cancel, so we are left with the integral. That is now 1, so 1 du over 3u, which is equal to the integral of 1 over 3 times 1 over u du. We can take the third outside, so therefore we've got 1/3 the integral of 1 over u du. If you integrate 1 over u, that is equal to log u. So therefore we've got 1/3 log u. We can now substitute back in plus c. So therefore we've got 1/3 log u is equal to x cubed plus 1 plus c. Another one, use integration by substitution to find the integral of x squared e to the power of x cubed dx. The parent function in this case is x cubed, so put that equal to u, so we get u equals x cubed. Differentiate, you get du over dx is equal to 3x squared. Rearrange, so we get du equals 3x squared dx. So therefore dx equals du over 3x squared. Substitute back into the original, so we get the integral of, don't forget it's going to be a division, so x squared is still there, e is still there, but it's x cubed is now u, and now dx is equal to du over 3x squared. The x squareds cancel, so we are left with the integral of 1/3 e to the u du, which is equal to the 1/3 the integral of e to the u du. The integral of e to the u is just e to the u, so therefore we've got 1/3 e to the u plus c. Substitute back in for u, so therefore the integral is 1/3 e to the x cubed plus c. One final one, use integration by substitution to find the integral of 8x over 1 minus x squared raised to the power of 4 dx. The parent function in this case is 1 minus x squared, so put that equal to u, so u equals 1 minus x squared, so du over dx is equal to minus 2x. Rearrange, so you get du equals minus 2x dx, so dx is equal to du minus du over 2x. Substitute back in, so you get the integral. Remember, you're going to have a quotient, so the 8x is still there. 1 minus x squared is now u, so you get u to the 4, and dx is now minus du over 2x. The x's cancel, and the 8 and the 2 cancel to give 4. So therefore you've now got the integral of minus 4 du over u to the power of 4, which is equal to, take the minus 4 outside, so you get minus 4, the integral of 1 over u to the 4 du, which is equal to minus 4, the integral, bring the u to the top, so you get u to the minus 4 du, which is equal to minus 4, add 1 to the power, so you get u to the minus 3, divide by the new power, minus 3, plus c. Substitute back for u, so therefore you get 4 over 3, the minuses cancel, u is 1 minus x squared to the minus 3 plus c.